There are over 20 web browsers available right now. Chrome, Edge, Firefox, Safari, Brave, Vivaldi, Opera, Arc. The list keeps going. But almost all of them are the same browser underneath. Different name, same engine. Today, we are breaking down how every major browser actually works, what makes them different, and what you should care about. The rendering engine. Every browser has a core piece of software called a rendering engine. This is the component that takes raw code, HTML, CSS, and JavaScript, and turns it into the visual web page you see on screen. The rendering engine is the browser. Everything else, the tabs, the bookmarks, the address bar, that is just the interface wrapped around it. There are only 3 rendering engines that matter. The first is Blink. Blink is developed by Google as part of the Chromium open source project. Chrome uses Blink, Microsoft Edge uses Blink, Brave uses Blink, Vivaldi uses Blink, Opera uses Blink, Arc uses Blink, Samsung Internet uses Blink. Every one of these browsers, despite looking completely different on the outside, renders web pages the exact same way. They're all Chromium browsers wearing different outfits. The second is WebKit. WebKit is developed by Apple. Safari uses WebKit. On iOS, every browser uses WebKit because Apple requires it. That means Chrome on your iPhone is not actually Chrome. It's WebKit with Chrome's interface on top. Apple does not allow third-party rendering engines on its mobile platform. The third is Gecko. Gecko is developed by Mozilla. Firefox uses Gecko. That is essentially it. LibreWolf, WaterFox, Florp, and Zen are forks of Firefox, so they also use Gecko, but they are all derivatives of the same codebase. So when you look at the browser landscape, what looks like 20 choices is really 3 engines, and one of them, Blink, powers roughly 65 to 70% of all web traffic globally. Expert aside, Blink was originally forked from WebKit in 2013. Apple developed WebKit, and Google contributed to it for years while building Chrome. Then Google split off and created Blink as its own project. So Blink and WebKit share a common ancestor, but they have diverged significantly over the past 13 years. The practical consequence is that Google now controls the dominant rendering engine and the dominant browser, which gives it enormous influence over how web standards evolve. The JavaScript engine. Rendering HTML and CSS gives you a static page, text and images in a layout. To make that page interactive, to make buttons work, forms submit, animations play, data load without refreshing, you need JavaScript, and every browser has a separate engine just for running JavaScript. Chrome and all Chromium-based browsers use V8. V8 is one of the most sophisticated pieces of software Google has ever built. It compiles JavaScript directly to machine code using a technique called just-in-time compilation, or JIT. That means the code does not get interpreted line by line. It gets converted into native instructions that your CPU can execute directly. This is why modern web apps, things like Google Docs, Figma, Notion, can feel almost as fast as software installed on your computer. Safari uses JavaScript Core, also called Nitro. It uses a similar JIT compilation approach, but is optimized specifically for Apple hardware, especially the M-series chips. Firefox uses SpiderMonkey. It was the original JavaScript engine, written by Brandon Eich in 1995, the same person who created the JavaScript language. SpiderMonkey has been completely rebuilt multiple times since then, but it carries the distinction of being the first. Expert aside, V8 is not just a browser technology, it's the foundation of Node.js, the runtime that lets developers run JavaScript on servers. That means Google's JavaScript engine powers both the client and the server for a significant portion of the internet. When Google makes changes to V8, it affects web applications, server infrastructure, and desktop tools built on Electron, which includes apps like VS Code, Discord, Slack, and Notion. Tabs, processes, and why your browser uses so much RAM. Open Chrome right now and look at how much memory it's using. If you have 15 tabs open, you might see 3, 4, even 6 gigabytes of RAM consumed. People treat this as a bug. It's not a bug, it's a deliberate architectural decision. Chrome runs each tab as a separate process. In your operating system's task manager, you will see one Chrome process for every tab, plus additional processes for extensions, the GPU, utility services, and the browser frame itself. 15 tabs might produce 25 or 30 processes. This design is called process isolation, and it exists for two reasons. The first is stability. If one tab crashes, it should not take down the other tabs. The tab goes white, you get an error message, but everything else keeps running. Before process isolation, a single bad website could crash your entire browser and take all your open tabs with it. The second reason is security. Process isolation creates a sandbox. Each tab runs in its own restricted environment with limited access to the rest of your system. A malicious website in one tab should not be able to read the cookies, passwords, and data in another tab. The process boundary acts as a wall. The cost of this architecture is memory. Every process needs its own allocation of RAM. Shared libraries get duplicated across processes. The overhead adds up. Firefox takes a different approach. It uses a system called electrolysis, which separates content processes from the browser process, but it shares content processes across multiple tabs rather than isolating each one individually. This uses less memory but provides slightly weaker isolation between tabs. Privacy architecture. This is where browsers actually differ in ways that matter to you. Chrome collects data. It is a Google product. By default, Chrome syncs your browsing history, bookmarks, passwords, and autofill data to your Google account. It sends usage statistics and crash reports to Google. It uses a unique client identifier tied to your installation. Chrome is free because you are the data source that feeds Google's advertising business. Edge is similar. It is a Microsoft product built on Chromium. It syncs data to your Microsoft account. It sends telemetry to Microsoft. It also includes features like Bing integration, Copilot AI, and shopping tools that generate revenue for Microsoft through engagement and data collection. Safari is more private by default. Apple's business model is hardware, not advertising, so Safari's incentives are different. Safari includes a feature called Intelligent Tracking Prevention, or ITP, which uses machine learning to identify and block cross-site tracking cookies. Safari also blocks fingerprinting by presenting a simplified system profile to websites, making it harder to identify your device based on its configuration. Firefox includes enhanced tracking protection, which blocks third-party tracking cookies, fingerprinters, crypto miners, and social media trackers by default. Firefox is developed by Mozilla, a nonprofit. Its revenue comes primarily from a search engine deal with Google, which creates an awkward dependency, but the browser itself is open source and auditable. Brave takes privacy the furthest among mainstream browsers. It blocks ads and trackers at the engine level by default. No extensions needed. Brave strips tracking parameters from URLs, blocks fingerprinting attempts, and upgrades connections to HTTPS automatically. It also includes a built-in Tor window for anonymous browsing without installing a separate application. Expert aside, LibreWolf is a Firefox fork that goes farther than Firefox itself. It disables all telemetry, removes Mozilla's Pocket integration, uses a privacy-focused search engine by default, and ships with the uBlock Origin ad blocker pre-installed. It does not phone home to Mozilla at all. The trade-off is that you lose automatic updates and some convenience features, but if maximum privacy with a non-Chromium engine is the goal, LibreWolf is the cleanest option available. The Brave attention economy. Brave is the only browser that has tried to redesign the economics of the web, not just the technology. It blocks all third-party ads by default, then offers you the option to view Brave's own ads in exchange for basic attention tokens, or BAT, a cryptocurrency on the Ethereum blockchain. You see an ad, You earn tokens. The advertiser pays Brave. Brave keeps 30%. You get 70%. You can cash out, tip creators, or auto-contribute to sites you visit. Whether this model works at scale is an open question. DAT's value fluctuates, the inventory is limited, and most Brave users never interact with the token system. They just use it as a fast, private browser with a built-in ad blocker. Extensions and Manifest v3. Browser extensions are small programs that modify how your browser behaves. Ad blockers, password managers, dark mode tools, tab managers, developer tools. Chrome's extension store has 125,000 extensions.
Extensions run with permissions you grant, and those permissions can be significant. An extension with access to all sites can read and modify every web page you visit. It can see your cookies, your form inputs, your browsing history. This is how ad blockers work. They need to see the page content to identify and remove ads, but it is also how malicious extensions steal data. In 2024, Google began enforcing Manifest v3, a new extension framework for Chromium browsers. Manifest v3 changes how extensions interact with web traffic. Under the old system, Manifest v2, extensions could intercept and modify network requests in real time using a feature called the Web Request API. This gave ad blockers like uBlock Origin full control over what loaded on every page. Manifest v3 replaces this with the Declarative Net Request API, which limits extensions to a fixed set of rules that the browser evaluates itself. The extension declares what it wants to block, but the browser decides how and when to apply those rules. Google says this improves performance and security. Critics, including the developer of uBlock Origin, say it fundamentally limits what ad blockers can do. uBlock Origin Lite is the Manifest v3 compatible version. It works, but it is less capable than the original. It cannot apply cosmetic filtering as aggressively, and its rule limit means it cannot match the full filter lists of the original. Firefox supports Manifest v3, but has kept support for the Web Request API alongside it. This means uBlock Origin continues to work at full capability on Firefox. This is a practical, measurable difference between the two platforms that affects millions of users who rely on ad blocking. Expert aside, this is not a small technical detail. Google's advertising revenue was over $300 billion in 2025. Ad blockers directly reduce that revenue by preventing ads from loading. Google controls the Chromium project. Google decides the extension framework. Manifest v3 makes ad blockers less effective on Google's browser. The conflict of interest is architectural. Which engine matters and why? This is the part that most people skip, but it is arguably the most important. Web standards, the rules that determine how websites are built, are developed through a process that involves browser vendors, developers, and standards bodies like the W3C. But in practice, if Google implements a feature in blank and 65 to 70% of web traffic runs on blank, that feature becomes the de facto standard, whether the W3C approves it or not. Developers build for Chrome first, because that is where the users are. Other browsers follow or lose compatibility. This is why Firefox matters, even if you do not use Firefox. It's the only independent check on Google's ability to dictate how the web works. If Firefox disappears, Google and Apple are the only two parties with a rendering engine. And on iOS, Apple forces everyone to use WebKit anyway, so even that check has limits. A healthy web requires at least 3 independent rendering engines with meaningful market share. Right now, Gecko has under 4% global share. That number has been declining for years. Whether you use Firefox or not, its survival affects the openness of the platform you use every day. So what should you actually use? There is no single best browser. There's a best browser for what you care about. Chrome is the standard, fastest, most compatible, built for Google's data pipeline. Edge is the same engine with Microsoft's data pipeline instead. If you don't mind the data collection, everything works. Brave gives you Chromium compatibility with privacy defaults and a built-in ad blocker, no extensions needed. Firefox is the only mainstream browser running a non-Google engine, full-power uBlock Origin, open source, and the only independent check on Google's control of the web.
Safari is optimized for Apple hardware, best battery life, tight keychain and handoff integration, solid privacy defaults through intelligent tracking prevention. LibreWolf is Firefox with everything stripped out. No telemetry, no tracking, no pocket. Maximum privacy without configuration. The browser you choose determines who controls how you see the web, what data you generate, and who profits from your attention. That's not a software preference, that's an infrastructure decision. Subscribe. Sudo BitLogic is just getting started.